Hey guys, happy Tuesday. Let's just double check to see how you're doing with memorizing different fractions with degrees on a circle. So here comes some questions for you. Now let's focus in on that last one, which is the 30 degrees. 30 degrees represents 1/12 of a circle. Now luckily for you, clocks are split up into 12 equal parts, as you know, because there's 12 hours on a clock. Now, when you look at a clock, one cool thing that maybe you didn't know before is that most of you should be able to see that this is a right angle, that it's going to measure 90 degrees. Well, if that's true, then if I was to split this right angle into three parts, right, 1/3, 1/3, 1/3, that from here to here would have to be 30 degrees. From here to here would have to be 30 degrees. And from here to here would have to be 30 degrees. Now what's interesting is basically from one number to the next on a clock would be 30 degrees. And that's really helpful because depending on what time it is, you should be able to look and see how many degrees that would be based on the fact that from one number to the next is 30 degrees. So let's say that the time looked like this, and it's 1 o'clock. Well, I asked you how many degrees is this angle? Well, we know it's an acute angle. It's definitely going to be less than 90 degrees, because a 90-degree angle would be 3 o'clock. But I automatically know exactly how many degrees without having to take a guess, because it's literally one ray is on the 12, one ray is on the 1. That would be 30 degrees exactly. Notice how it's a third of a right angle, and that is 1/12 of my circle. What if I asked you this time, 2 o'clock? Well, we know that from 12 to 1 is 30 degrees, and from 1 to 2 is 30 degrees. So how many degrees is that? That should be 60 degrees total, because 30 plus 30, or 30 times 2, is equal to 60. How many degrees is this angle? Well, can't you see that it's a right angle, right? So this would be 30 plus 30 plus 30, which would be 90 degrees. What about this angle? Do you notice how this angle is no longer acute? It's greater than that 90-degree angle like we just did. Therefore, it's an obtuse angle. And if we know that each one of these sections here is a 12th, that's going to be 30 degrees, that's 30 degrees, that's 30 degrees, and that's 30 degrees. Do you see how there's 4 groups of 30? That's 30 plus 30 plus 30 plus 30, or 30 times 4. How many degrees is that? That would be 120 degrees from here to here, which makes sense because 120 degrees is an obtuse angle measurement. What about here? Well, if we know that from 12 to 4, what we just learned before, is 120 degrees, all we have to do is just add another 30 degrees to it. 120 plus 30, if you put those two together, would be 150 degrees. Again, doesn't that make sense? Because this is an obtuse angle measurement. Now what if it was exactly 6 o'clock? Well, can't you see right here that this is a straight angle? Straight angles always have exactly 180 degrees. And if you think about it, here to here is 30, 30, 30, 30, 30, and 30. That's 6 groups of 30. 6 times 30, if you use the quick trick, is 6 times 3 is 18. Then attach your 0. That's 180 degrees, which is exactly what we were thinking it would be. Do you also notice that that is half of a circle? Since a whole circle is 360 degrees, half of the circle is going to be 180. Now here's where it gets a little tricky. What if the time was 4:30? Well, if you know that the ray is now in between the 4 and the 5, it's halfway in between the 4 and the 5. Well, if we know that from here to here is 30 degrees. Well, if this is halfway in between that, then that would have to be 15 degrees here, and then 15 degrees on the other side of it, right? So we know that that's got to be 15 degrees because it's half of the 30 degrees. And then here we would have 30 degrees because it's going from 5 to 6. Do you see that that is 30 degrees plus 15 degrees, which is 45 degrees? As you know, this is an acute angle measurement. And if it's truly 45 degrees, remember that that is half of 90 degrees, right? So if I look at my diagram, I have a 45 degree angle right here. And then if I notice this is half of a 90 degree angle. Well, a 90 degree angle is 1/4 of a circle. A 45 degree angle, if you remember, is 1/8 of a circle. What if the time was 3:30? Well, again, we know that if I'm counting from 5 to 6, that'd be 30 degrees. 4 to 5 would be 30 degrees. But this ray is not on the 3. It's halfway between the 3 and the 4. So I'm basically going to have to decompose that 30 degree angle, which is right here, decompose it into this is 15 degrees and this is 15 degrees, right? So since it's only from here to here, I'm going to add 30 plus 30 plus 15. This is not included because that's larger than what the angle is showing. So 30 plus 30 plus 30 will tell me my angle measurement, which in this case would be 75 degrees, which again should make sense to you because this is an acute angle. It's less than the 90 degrees. What about this time? 1:30. Well, I know that from here to here is 30 degrees. I know from here to here is 30 degrees. I know from here to here is 30 degrees. Here to here is 30 degrees. And since this is halfway, this would be 15 degrees. Now, first thing that I notice is that this angle is an obtuse angle measurement. So I'm going to add 15 plus 30 plus 30 plus 30 plus 30, right? 30 times 4, as you can see, is 120, plus the 15, that'd be 135 degrees. All right. What kind of angle is this? Hopefully you notice that this is an obtuse angle measurement because it's greater than 90 degrees, right? Here's a 90 degree angle, and you can see that it's greater than that, but it's less than 180 degrees, which would be from here to here, right? So it's in between 90 and 180 degrees, which is what we would call an obtuse angle. True or false? This angle is greater than 1/4 of a turn, but it's less than half of a turn. This would be true. Here's why. 1/4 of a turn is 90 degrees, right? If you remember from the very beginning of our refresher from yesterday, and half of a turn is 180 degrees, right? So here's 1/4 of a turn, because if you notice, it is 1/4 of a circle, right? It's bigger than 1/4, but it's less than a half, right? You can see that it's not entirely half the circle. So sometimes in math we have to estimate how many degrees this actually is, right? It's not enough to always just say, well, I know it's obtuse, right? We're going to have to determine the best estimate of this degree. So we know it's bigger than 90 and we know it's less than 180, right? So here's the 180 degree mark. Here's the 90 degree mark. We know it falls in between them. Now it almost seems like it falls halfway in between 90 and 180. Well, if we know that this side is 90 degrees, well, 90 plus 90 gives you 180, so wouldn't this side also have to be 90 degrees, right? And if that's true, we're basically splitting that 90 degree angle in half, right? Half of 90 is 45 degrees. So what you're noticing is, from here to here, if we made a prediction, would probably be 45 degrees. But since the entire angle is from here to here, we're not only going to include the 45 degrees here, but we're also including that 90 degrees here, right? So this is 90 degrees plus the 45 degrees. That would be an obtuse angle measurement that's probably 135 degrees. Do you notice how we sometimes have to estimate a little bit to see? How many degrees do you think this is? Well, first thing that you should always do is determine what kind of angle is it. Is it acute, right, obtuse, or straight? Because obviously, if you think it's obtuse, right, then your measurements are going to be really high. If you think it's acute, your measurements are going to be really low. In this case, we would say it's an acute angle. Acute angles always measure less than 90 degrees, right? So if I imagine a 90 degree angle, this is probably what a 90 degree angle would look like, right? It seems like it's way less than 90 degrees. If you think about like the halfway point like we were just doing in the other one, this is about the halfway point, right? The halfway point says that this right here would be 45 degrees. So we know it's got to be even less than 45 degrees then, right? Because this is almost seems like it's half of 45. And half of 45 would be something like around here, right? You might even say that maybe a good estimate might be 20 degrees, or 21 degrees, or 22 degrees, something along those lines. And since we're estimating, I'm not expecting you to be like perfect or exact, right? That's not the purpose of an estimate, is to be exact. It's exciting when you are exact, but you know, as long as you're within like 5 degrees, that's probably okay. And saying like this might be 20 degrees makes sense because it is an acute angle measurement and it's definitely less than 45 based on what we just decided there. What about this angle? How many degrees do you think this is? Well, again, think, is it acute, right, obtuse, or straight? And that will help you determine what kind of degrees we should even be considering. Well, we know it's not acute because it's not less than 90. We know it's not right because it's not exactly 90. We know it's not obtuse either because it is actually straight. It's bigger than 90 degrees, yes, but it's actually exactly half of a circle, right? Here's my circle. It's exactly half of my circle. That would be 180 degrees exactly. What about this angle measurement? Well, again, first think, is it acute? Well, acute angles have to be less than 90 degrees. Here is maybe what a 90 degree mark would look like, although that wasn't perfectly straight, and that probably will never be perfectly straight, but I'll try and make that a little bit more accurate. Here's what 90 degrees would look like, right? It's definitely more than 90 degrees. See that, how it's a little bit greater than that? It's definitely not 90 degrees exactly either, it's just a little bit beyond that. And I wouldn't say it's straight, so I would say it's obtuse. Now because it's obtuse, I know that this is 90 degrees right here. It looks like it's a little bit beyond the 90 degree mark. Now, it's probably going to be more so like 5 or 10 degrees higher than 90 degrees because it's not like it's halfway in between, right, what 180 degrees would be, because this would be the 135 degree mark, right, because 90 plus 45. So it's not even anywhere close to the 135 degree mark, it's just a little bit closer to 90. So it might make sense to say that this is 95 or maybe even 100. Let's just say it's 100, just to make it nice and simple. This would make sense because that is an obtuse angle measurement. Now it's always important that your degrees that you say make sense, right? So if you say, you know, this is an obtuse angle and I think it's 15 degrees, Well, that makes no sense at all because 15 degrees would be an acute angle measurement, which is not what we said in the very beginning. What about this angle? Acute, obtuse, right, straight? Let's first start there. Well, it's definitely not right. It's not exactly 90 degrees. That's what 90 degrees would look like. It's not obtuse because it looks like it's less than 90 degrees, and it's definitely not straight. So we would say it's acute. Acute angles have to be less than 90 degrees. And as you can see, it's definitely less than it. Now if you remember, here is where the halfway point is in between. Here's 0 degrees, right? Here's 90 degrees. Halfway in between 0 and 90 is 45. Would it make sense to say anything lower than 45 degrees? Absolutely not, right? It's bigger than that. So from here to here, yes, it's 45 degrees, but it's a little bit bigger than that, right? Maybe you add another 10 degrees to it, right? If you think back to the one that we just did, from here to here, that turn was about 10 degrees, like what we added on the last one. So we might say, here's 45 degrees, plus another 10 degrees, that'd be about 55 degrees. Now think, does that make sense? Yep, because it's less than 90, and we said it's acute. Alright, what I'd like you to do is turn to page 12 in your packet. Math packet number 7, of course. This is what page 12 looks like. We're going to be practicing estimating angle measurements, and we're going to be given multiple choice, and that's going to make our life so much easier. Not only are we going to decide if it's acute, obtuse, right, or straight, but then we can actually eliminate answer choices that just don't make any sense, right? So every single time, we're first going to identify what kind of angle it is, and then we're going to start eliminating from the choices, and hopefully be left with one that seems to make sense. You can look at the example up at the top. They do the same thing, where they kind of eliminate ones, and then identify which one is left over. Alright, here we go. Question 1. First, identify, is it acute, right, obtuse, or straight? Okay, and I want you to literally just write one of those letters somewhere in the white space. So in this case, we would say it's an acute angle because it's less than 90 degrees. I want you to actually draw that where the 90 degree mark would be, right, to make that perfect right angle. Now, if it's truly acute, it definitely can't be 90 degrees exactly because that would be right. And it can't be 140 degrees because that's obtuse. So we're only left with 15 degrees or 40 degrees. Now think, does it look like it's about halfway? Gosh, that was terrible. Sorry. Does it look like it's about halfway in between 0 and 90? Because if it is, the halfway point is about 45 degrees. So do you think that it's 15 or do you think it's 40? Hopefully you're recognizing it'd probably be 40 degrees then, because 15 would be even closer to 0. Alright, look at number 2. Is it acute, right, obtuse, or straight? Well, if you could put a piece of paper right here in the corner, it would be a perfect square corner, measuring exactly 90 degrees. Well, if it's truly exactly 90 degrees, then it can't be B, A, or C, right? The only one that's left is choice D, 90 degrees. Alright, look at number 3. Draw your 90 degree mark. Now that 90 degree mark is helping you identify as acute, right, obtuse, or straight. In this case, we would say it's acute. I'm putting an R for right on my other one. Now if it's truly acute, let's eliminate. Well, it could be A if it was acute, and it could be B if it was acute, but it definitely can't be C, and it can't be D, right? So we have to think, is it 15 degrees or we think it's 70 degrees? Well, if it was 15, it'd be closer to the 0. If it was 70, it'd be closer to the 90, right? Well, it looks like it's pretty close to the 0. This is not that big of a turn. So it's probably 15 degrees because a 70 degree angle would probably be more so like this. This right here would probably be 70. So I'm going to go with 15 degrees. Alright, now that we've done some together, I want you to try and do some on your own. So I'm going to give you about a minute, minute and a half. I want you to identify as acute, obtuse, right, or straight. put A, R, O, or S, and then eliminate and choose your answer. So I'll give you about a minute, minute and a half to do these three. Go ahead. Alright, even if you're not done, let's just check in to see how we're doing. I want you to put a check if you're right, and if you get it wrong, put an X. Okay? So, first thing that I notice is that here's the 90-degree mark, like I always tell you to do, right? Make your little 90-degree mark. You can also tell that it's bigger than 90 degrees, but less than 180. I'm making that other mark there. If it's bigger than 90 but less than 180, we would say it's obtuse, right? Now immediately I can eliminate A and I can eliminate B because those are both acute measurements. Then I have to determine, is it 110 or 160? Now remember, here's the 180 degree mark, and here is the 110 degree mark. Or, sorry, not 110. Here's the 90 degree mark. Now 110 would be closer to 90, probably be something more like this, right? Or more like that. This seems to be bigger than that. It's closer to the 180 than it is the 90, so I would say D, 160. Again, give yourself a check if you got that right. Let's go to number 5. This would be obtuse. It's bigger than 90 degrees, but just slightly bigger than 90, right? So I know it's not A, I know it's not B, because those are both acute. And then, since I said it was just slightly bigger than 90, it would probably make sense to say that it is 95 degrees, not 125, because 135 would be halfway in between the 90 and 180 degree mark, right? So here's 135. You can see that if this is 90 degrees and that's 135 degrees, it's a lot closer to 90 than it is 135. So it's not going to be D either. Looking at number 6, we would say this is an acute angle because it's slightly less than 90 degrees, as you can see. So I know it's not C and I know it's not D. Now notice how I said it's slightly less than 90 degrees, right? A 30-degree angle measurement would be the distance on a clock from like 12 to 1. Well, it's definitely larger than that, right? So I know it's not A. It's almost 90 degrees, so I would say that this angle right here is probably 80 degrees. Check in with yourself. See how you did. Did you get all 3 of those right? If not, keep persevering. If you did, let's see how you do on the next ones anyways. 7, 8, and 9. Go ahead. Same deal. A, R, O, or S, and then eliminate and choose. Alright, let's go ahead and check in to see how you did this time. Same deal as last time. Let's put a check if you're right, X if you're wrong. Here's the 90 degree mark. Here's the 180 degree mark. Okay, and I know I'm not drawing them perfectly, but you get the idea. You can obviously tell it's bigger than 90, but it's less than 180. This is what we would call an obtuse angle, right? So we know it's not A, we know it's not B, because those are acute. We also know it's not C, because that's right? So the only one that's left would be D, 120 degrees. We don't have to really think much more on that one. Number 8, same deal. It's larger than 90, but it's less than 180 degrees, right? So I know it's an obtuse angle measurement. I know it's not A, I know it's not B. Those are acute. C and D are both obtuse, but D, if you think about it, here's the 180 degree mark. It's not anywhere close to the 180 degree mark. It's almost halfway in between the 90 degree mark and the 180 degree mark. The halfway point, if you remember, is 135 because that's 90 plus 45, right? But it's not 175 degrees because 175 degrees would be so close to the 180 degree mark. So it's not D, it's got to be C. How you doing so far? Hopefully we got both those right. Let's look at number 9. Here's my 90 degree mark. I can tell already that it's less than 90 degrees, so we would say it's acute. It's definitely not D then, that's obtuse. It's definitely not C because it's not exactly 90 degrees or a right angle. And then we're just left with A, which is 60 degrees, or B, which is 80. Now, this one's going to be a little tricky here because if I look at this one, here is the halfway point, right? Halfway between 0 and 90 would be 45. It looks to be pretty close to the 45 degree. So I'm looking for a measurement that's probably closer to 45 than it is to 90. 80 degrees is only 10 degrees away from 90. 60 degrees is 30 degrees away from 90, right? As you can see, the distance from here to here, or the turn, is going to be smaller than the turn from here to here, right? 60 degrees is only 15 degrees more than 45. I'm probably going to lock in A here as my answer, because if this is 45 degrees, and I just add 15 degrees, which is probably what this angle is right here, then that would give me 60 degrees. How'd you do on that? Hopefully pretty well. Let's keep going. Now, estimating angles can be really challenging because you're kind of taking a little bit of a guess, a little bit of a ballpark, and it gets a lot easier when you're given multiple choice options, but you're not always given multiple choice options, and you sometimes have to guess, within 5 degrees how many degrees that could be, and it just takes practice, right? But the cool thing is, you don't always have to estimate your degrees. You can actually find out exactly how many degrees an angle is using what's called a protractor. A protractor is a tool that's actually in your math kit. So if you have your math kit with you, you can take it out, and if you don't have your math kit with you because you're in person right now and you don't have it at school, that's totally fine. But you can get one. You can get it out of your math kit and bring it with you to school tomorrow. It's not that big of a deal. But they're really cool tools that you can put on top of angles that have already been drawn, and you can measure exactly how many degrees that is. And so that's what we're going to be using today, is we're going to start to use a protractor to measure those degrees. This is what it looks like. The first thing that you should notice about this is that it's basically half of a circle, right? It's not like this whole circle, it's about half of a circle. Now if you remember, half of a circle is 180 degrees. If this was a ray right here, this was your other ray, and this was your vertex, this angle from here to here would measure 180 degrees. As you can see, the numbers start at 0 and work their way all the way around to 180 degrees, right? Here's the 180 degree mark. Here's the 90 degree mark. If I was just a little bit more accurate, there we go. Here's the 90 degree mark, right? If you notice the halfway point in between the 0, here's 90, Here's 180 degrees. If you notice the halfway point in between those two, sorry, gosh, it's hard to draw on a computer. You can see that that is the 45 degree mark like I've been talking about, right? Do you see how it's halfway in between the 40 and the 50? Right, that's the 45 degree mark. Notice that little tick mark right here, that's a little bit longer. That's the halfway point in between 40 and 50. Now what can be a little bit confusing about a protractor is that there's two sets of numbers, right? I'm currently looking at the numbers on the inside track, right? From 0 all the way to 180 degrees. But you can also see that on the outside track, over here is going from 0 all the way to 180 degrees. That's because it depends on which way the angle is opening towards. Like for example, if I had an angle that was measuring from here to here, right? You can notice that that is an acute angle. And so you wouldn't be looking at the higher set of numbers because the higher set of numbers go with obtuse angle measurements, right? That are going to be bigger than 90. So when you're looking at it, if it's an acute angle, which is why it's always important to identify what kind of angle you're looking at, then you're going to look at the smaller numbers. But if I asked you to look at the angle, let's say from here to here, do you see that this angle is greater than 90 degrees? This is what we would call, in pink, this would be an obtuse angle measurement. You can tell that from here to here is 90 degrees, right? But then it's bigger than 90 degrees. So since it's bigger than 90 degrees, we're not going to look at the smaller numbers, we're going to look at the larger numbers. Do you see how this falls in between 130 and 140, right? As you're counting, you're going 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. Notice how it's halfway in between 130 and 140. That would be 135 degrees. Which should make sense because we're adding that 45 degrees from here to here with the 90 degrees that's there as well. 90 plus 45 is 135, right? So, depending on if you're looking at an obtuse angle, you're looking at the bigger numbers. If you're looking at an acute angle, it's the smaller set of numbers. Let's do some practice ones together. Oh, by the way, if you're using a protractor and you're trying to measure an angle, before we look at some practice ones, it's important that you recognize that there's different points on the protractor that need to be used. So see how the vertex of the angle needs to be right in line with this vertical line on the protractor. Every protractor is a little bit different, but the protractor that we're looking at, that vertex needs to go right on the center point of your protractor. Then also you have to make sure that the bottom ray of your angle is in line with the bottom line of the protractor, right? So that's with the 0 degree mark. Then also, because rays can be extended infinitely, right? That's the whole purpose of the arrow. You can extend them infinitely. When you look at this angle, it's kind of hard to eyeball exactly where does that ray intersect on this on these tick marks, right? So what you can do is you can actually extend the rays. And so, for example, on this one, we would identify that this is an acute angle, right? And because we extended the rays, we're actually not changing the angle measurement. As it says, like, extending the rays of angle will change the angle measurement. That won't change the angle's measurement. And since we know that it's an acute angle, right, if we decide A, R, O, or S, we then would decide that, see how it's going? It's going through the 60 and the 120 degrees. Well, we're going to identify this as a 60 degree angle measurement because that makes more sense than 120, right? Because if it's an acute angle, how could it measure 120 degrees? By definition, acute angles measure less than 90. Last I checked, 120 is bigger than 90, right? So that's typically how you would use a protractor. And honestly, all the ones that we're going to look at today, the angles are already on the protractor, so you don't even have to worry about placing the protractor on top of the angle. But in case you want to use your math kit one and just put it on top of different angles, especially on page 12, so you can double check exactly how many degrees that is, you can do that. The only thing about page 12, if you remember, the angles themselves are, the rays are pretty small. Like in number 9, you might have to extend those, and typically you use a straight edge, and the nice thing is you can use the protractor flat edge to help you extend them out, and then you can measure exactly, and you put the vertex right in the center point. But for now, let's just keep moving and measure some angles that are already on the protractor. So go to page 14 in your packet. Now, I apologize, this didn't copy overly well, but I hope you can see the numbers on the protractor. I will help you out quite a bit. So you can see that the angle has already been put on the protractor for you. Notice how the vertex is right on the center point. The ray, the bottom ray, is in line with the 0. Okay. The first thing that you should always do is identify, is it acute, right, obtuse, or straight? Aros, I guess you could call it, right? And in this case, you can see that it is less than 90 degrees, right? So here's the 90 degree mark. It's obviously less than 90 degrees, so we would say it's acute. Now, if it's acute, you're going to be looking at the smaller set of numbers then, right? Because if it was obtuse, you look at the bigger set of numbers. Now, this number down here says 0. It says 10, 20, 30, 40, 50, 60, and here's 70. So do you notice how it's in between? It's halfway in between 60 and 70. If that's the case, halfway in between 60 and 70 would be 65 degrees, right? Now, the most common mistake that I ever see students do is they notice it's in between 60 and 70, and they just decide to add 5 more degrees to 70 and call it like 75 degrees. But 75 degrees isn't in between 60 and 70, right? 75 degrees would be right here. And so we just have to be really careful. I always tell students to start at the bottom rate and work your way up. That way you don't accidentally count incorrectly. So 0, 10, 20, 30, 40, 50, 60. It's halfway in between 60 and 70, so it's 65 degrees, and that makes sense because it's acute, right? Let's look at the next one. Here's the 90 degree mark. You can see that it's bigger than 90 degrees, so we would say it's obtuse. And if it's obtuse, then we're looking at the bigger set of numbers, right? So we're looking at the bigger set of numbers. We are looking, when we're looking at these numbers, here's a 60, and here's 120. Now we know it can't be 60 because that's what the acute angle is, right? And 120 would make sense. Now, if you're having a hard time reading, what you can do is you can start at the 0, right? You're always starting at the 0, wherever that bottom ray is, and count 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and 120. So this would be 120 degrees, which should make sense to you because it's an obtuse angle measurement. Alright, let's try one more together and then let's see if you can do number 4. Number 3. Do you see how it's slightly bigger than 90 degrees? Well, if it's slightly bigger than 90, but less than 180, we would call it obtuse. Now, if it's obtuse, we're looking at these two sets of numbers. I see one of them says 80, one of them says 100. Now, does 80 degrees make sense with obtuse? No, right? 100 degrees makes sense with obtuse because 100 is bigger than 90 degrees. So we would say 100 degrees. And if you're having a hard time reading the numbers, like I said, start at the 0 at the bottom ray. You don't want to ever start at the 180. Okay, you always start at the 0 wherever the bottom ray begins. You count 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Oh, I accidentally made a mistake. It's not 100 degrees. Good thing I'm doing that. Yes, this is the 100 and this is the 80, but it's not on the 100. Hopefully some of you were catching that as I was going through. I apologize. Sometimes teachers make mistakes too. But anyways, here's the 90. Here's the 100. Do you see how it's halfway in between 90 and 100? Well, halfway in between 90 and 100 would have to be 95 degrees. There we go. So I'm glad that I counted there from 0 up to 95, because I wouldn't have caught that. I would have kept going and never even realized my mistake. So, highly recommend it, because obviously I even caught my own mistake by doing that. Look at number 4 on your own. Identify if that's acute, right, obtuse, or straight. Hopefully you decided that's acute, right? It's less than 90 degrees. Now, if it's acute, when you're looking at it, you're not going to be looking at the bigger set of numbers, right? You're looking at the smaller set of numbers. So here I see 20 degrees and I see 30 degrees. Again, if you're having a hard time counting, you start at the 0, 0, 10, 20, here's 30. Notice how it's halfway in between 20 and 30. Well, halfway in between 20 and 30 is 25 degrees. Alright, number 5 and number 6. Is it acute, right, obtuse, or straight for number 5? Hopefully you said obtuse. Now, an obtuse angle measurement, we're looking at the bigger set of numbers, right? So we're not going to be looking at these guys here. We're looking at these guys here. If you're having a hard time reading it, that says 140, that says 150. So when you're counting, right, here's 0, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. It's halfway in between 140 and 150. Well, if this is 140 and this is 150, halfway in between those two numbers is 145 degrees. Okay, let's look at number 6. Is it acute, right, obtuse, or straight? Hopefully you said straight. Now if it's straight, isn't that pretty easy then? That's just half of a circle. It measures exactly 180 degrees. And that should make sense to you because you see two different sets of numbers, right? There's 0 or it's 180. If you start here on the left and think of the other ray on the right, well obviously it can't be 0 degrees, right? We're looking at the bigger number. This would be 180 degrees exactly. Using a protractor takes some time and some practice. So if this is your very first day ever using one, keep persevering. You can totally do this. It's just going to take a lot of practice. Alright, let's look at some examples of protractors that are not used correctly. What's wrong with this? Well, you can see that the vertex is right on the center point, but and the rays are extended beyond the protractor itself, so it goes through the tick marks. But what's not good is that the bottom ray is not on the bottom of the protractor or in line with the 0 degrees. Not to say that you can't measure this, because you technically could. This is 10 degrees here, this is 10 degrees here, and this is 5 degrees here, so technically this is a 25 degree angle, but that's a little bit harder than I want to go today. But if you understand that, great, that's 25 degrees. But honestly, this entire angle really should be moved down so that it looks something like, one second, if I do it like, I don't know if I'm going to be able to do this. I got myself into trouble here trying to do this. Well, it's not going to be perfect because I can't seem to get them straight. But do you see how that's 25 degrees now? It's an acute angle measurement. Alright, what's wrong with this one? Now hopefully you realize that the vertex is not on the center point. And it's so important that it's on the center point because right now you can see it's an acute angle measurement, but it looks like it's halfway in between 30 and 40. But don't let your eyes be deceived. Right now, we can't really measure that because technically that's not on the center point. And then if I put it on the center point, you see how it's actually bigger than that? It's actually a 40-degree angle. Just a common mistake that I see students do whenever they're using their real protractor. Now take a look at this guy. Now this is pretty gross because you should never try an eyeball like this. The rays are so small, and we know that by extending the rays, we're not actually changing the amount of turn at all. But if I was to extend, you might have something like this, and like this, and now that it goes through all the way, you can see that it falls in between 60 and 70 since it's an acute angle measurement. And it's not at the 65-degree mark. It's going 60, 61, 62, 63, 64, 65, 66, 67 degrees. So this is actually a 67-degree angle. Notice how it's only 3 degrees away from 70. Alright, so that's our lesson for today. Let's take a look at your independent work. Today you're going to have a protractor practice Google Slides. So, on Google Classroom, you'll see that this has been assigned to you. It looks just like this. There's a whole bunch of different slides, and I literally just want you to go through each slide and follow wherever the directions are on each slide. So for example, first slide, it's a study jams. I want you to have some fun with this. You're going to click the link. It's going to bring you to the website. I want you to do the step-by-step, and if you still have some time, you can even do the test yourself as well. Okay. After you've done that, this is just a review slide, just reviewing acute, right, obtuse, and straight. Just want you to read through that, make sure you understand it. This is just a review of what a protractor is, a definition of a protractor in case you need it. Here's another example of a protractor. Just another example of some vocabulary and some ideas of how to remember how to read the protractor. And then here comes the key part, and this is what you're going to be submitting today. So on the next 4 slides, you're going to be completing 4 practice problems. So on this particular protractor, not all protractors, the number goes all the way down to the bottom of the protractor. So see how the 0 is right here? And this is the center point of the protractor. It's almost like everything's been kind of shifted up, but this is actually drawn correctly. You don't have to move the angle at all. What I want you to do is to type the angle measurements here, and I want you to actually use the word. I don't want you to just do like A, okay, or R, or O, or S. So in this case, just giving you a hint, this is an obtuse angle measurement. And then since it's obtuse, I then want you to look at the larger numbers, right? So you can see that it's going to fall in between 50 and 60, or 120 and 130. So I want you to notice that it's in between the 120 and the 130. Here's the halfway point, but it's obviously not the halfway point. So here's 125. It's closer to 130 than it is 120. So my recommendation is to start at 120 and go 121, 122, 123, 124, 125, 126, 127. Maybe that's the answer. I don't know. And then type in your angle measurement. You're going to do that for the other 3 as well. And once you finish, then you're going to, it literally tells you, you're now finished. Now please click the Turn In button at the top on Google Classroom, and then you're done for the day. Now if you finish everything, you can do Dreambox, you can do Prodigy, you can do Penguin Jump or Division Derby. You can practice a little bit with your protractor to get more comfortable with that. You can go back to study jams and practice a little bit more with that. But I know today was a lot of new information, and especially if you've never used a protractor, congratulations on learning how to use it. It's an excellent tool. It's one of my favorite tools to use. And thanks for working hard today. Bye.